So the main project that we are working on, and I have a process, is making voice assistant. There are so many times that we just searched in the ChatGPT or maybe other LLM agents to know some real-time data. For example, the thing that I have mostly worked on is searching about apartments and knowing which one is available now, which price range does they have, and how many rooms there are, and which one is more appropriate for my special willingness. Hello everyone who is coming just now. Okay, I'll continue. ChatGPT maybe give you an answer, but you cannot rely on it because it may not be precise, because the data is always live and it's changing. Maybe the availability has changed or the price changed. We constructed a pipeline where the data is being scraped over time to be always up to date, and we can rely on it and to know every special attribute that we need for booking one. For example, I need to know an apartment which is under $900 and has two bedrooms. So the user sees only asking the voice assistant, and the system retrieves the information and gives an answer. What is under the hood? Anyone doesn't know. So I'll try to explain it, how it works, and what are the parts of it. So, as I told, the problems may be because the data is dynamic, it changes, it's inconsistent in the different websites, its structures are different, they have different HTMLs, JS renderings, and spread across the website, and it makes sometimes very difficult to scrape, even if the data is available in the HTML. You have to be aware to change the sources time by time. For example, what I mean that for one website you might need a scraper, a system doing a scraper, for example, Epify. Then you might see that it's not working for this one, and you have to have a fallback system, another scraping doing a system that will make this whole thing right, to not lose the information coming from that website. Afterwards, you have to store it in the database, or the first option that we were doing is storing it in the database, validating it before storing to have the good schema and structure of the tables and database, so that afterwards the data retrieval, the data searching, and other processes will be easy and will not take more time and will be very optimized. So the system's architecture is drawn there. It's first the voice input coming from the user, then it goes through the STT, which is speech-to-text transcript. There are different models to do STT. To have an optimized way of working, we have tried to use different STTs and to check which one is quicker, which one gives more reliability, and which one has less latency, because these are the two main things that we want to have in a good state: the low latency and good reliability. What I mean when I say that I want my name is Sarah Bennett, I don't want it to read I don't know, to read Sarah Benedict. The Benedict is my favorite breakfast, so I remembered it. So this is very essential because we want to get the authentication right, because we also consider the part of authentication very we put a lot of attention on it, because I don't want another person to know which apartments or maybe what businesses I own in some other business or some other things that are very personal, because I believe that for users, the personality and the security is very essential. So afterwards, it maybe took a little longer, but the second part is LLM reason. So we attach an LLM to it because just what comes after STT is just a text that user gave us. Maybe also it understood a little bit wrong, a little bit he left a little gaps, and LLM should understand it, should understand that I want $2,000 apartment is mean that I want to pay monthly for apartments so much money. So for understanding what the user said, we need LLM. Also, we can give the LLM a schema and structure to give in that way the data. So afterwards, we might not need it going over that data to put in some JSON type. Afterwards, we come the agent plan. Agent is not something just LLM and functions called on it. He should decide which function at this time he needs to call for executing the understanding of what user said. Maybe there might be a chance that we need live data, so we gonna need retrieving the information from the website, and we might need to attach an OpenAI web search to it to go through a website and extract the information real time. That's mostly about the scraping pipeline that I have just told, and then comes the validation before giving an answer to a user, because again, the JSON type is not that we are gonna put into the TTS, which is text to speech. Now, so the main, the data that we have at this point after LLM format is the text, which again needs to be converted to the speech again through some models. The models may be DeepGram or 11 Labs. These are the main models that LiveKit supports. LiveKit is a system that gives a lot of opportunities to make a voice assistant. Through LiveKit, you could give a call that is inbound calls, and then receive outbound calls, that is when the assistant calls to your phone. Like, isn't it amazing that an assistant can call you exactly on the time when your payment is coming to an end, and the same deadline that you have mentioned before, and there is no human working, and that is there is no human error, that someone couldn't call you, or they forgot. Just no one can forget if you are using voice assistant. So after LLM reasoning, then comes an answer, and live data is external. So the backend is essential part to connecting today's data with the models used. We need to control the data going over and over. There are budget, dates, locations. and we have to carry the state between changing data. Also, there are policies related to the business, and we should have a failure awareness. And our pipeline, when working, and sometimes he can fail, we should know what kind of failures they might be to stand them. For every failure, option, we need to know how to solve that. Overall, how to stand it. So, as I have told, if a scraper system, for example, Epify is not working, I have found another scraping system that is Zenrose. He has its MCP, a very good working compatibility with this whole pipeline. Or about STT or TTS or LLM models. There are a lot of models that we can try, and after one model is not working, we could have a try exact block, for example, and try another option for converting one type of data to another. Also, when the data is not available in the database, but the current user wants such kind of apartment exactly from this apartment building, we can go and use the OpenAI web search when we see that it is not available in the database. Also, why I spoke about Epify and Zenrose differences, maybe Epify, some of you know about Epify scrapers or actors that go and do Google search or other very convenient things, but sometimes it lacks the opportunity to scrape because the website has a very strong human identifying, or the GS rendering makes a lot of troubles, the captchas and other things. There is why Zenrose became my favorite one. It overcomes very easily. So we should know a lot of different ways to solve the same problem. The traditional extraction of data from some websites were like CSS selectors, HTML scrapping, just I have mentioned, and the other types like DOM specific rules. But when the data goes very inconsistent, the DOM rules might even make harm to a data extraction pipeline. And on the other hand, LLM-assisted extraction has a semantic understanding, adaptable extraction. So from the HTML, he could easily find the necessary information by checking the dollar symbols or other things under the hood to find the necessary type of attributes. But there is also a downgrade. LLM can hallucinate or give invalid fields, and sometimes there goes another problem. It's the cost effectiveness and the time that we don't have a lot. So we need to optimize it, and optimization comes with a lot of ways. For example, parallelizing earlier. We don't need to wait until the STT is totally and fully finished to start the LLM reasoning. When the first important and the first ready sentence is
What?
why don't you told it earlier? Okay. Optimization, the STT should be done not fully, and the reasoning should come until the STT ends, and same for TTS. When the first reasoning formatted text is ready, it should go already. Should transform the text to the speech, and other optimization techniques as well. The one that the one that came to my mind is using some pre-cached sentences. For example, hello, how can I help you on something like that, to be pre-reserved, so that the LLM will not put over time on thinking on it, and the TTS will work on it very quickly. And also, when the user interrupts the voice assistant, it should stop the generating, the reasoning, and other processes, because the information might be changed after the user's new words, and we do not need the same text that the LLM was about to generate. It should be very aware to interruptions, to listen to the new sentences, and try to generate on it. I might be going a little bit out of time, but that's all I wanted to introduce and tell about voice assistants and how I have created it. If there are some questions, I would be happy to answer that. Yes?
I have two questions. First, when you are telling about extractions of the materials from scrap data with LLMs, there is a problem that there are a lot of hidden text in that page, and it's used tokens as an input token. We send it to the LLMs, and it's make it more expensive for us to use. So how we can make a balance between that your
yes,
procedures and the traditional ways, and how we can customize the cost. It's my first questions. And one question.
The first thing that comes to my mind, if there are not thousands of websites that you need to scrape, sometimes you need to be aware what type of website it is. Maybe you could scrape or extract the information just using the classical ways, like Beautiful Soup or some other type of scrapers, when the information that is hidden inside some specific tags and not spread over the HTML. Or other technique, when you want to use only LLM, you could make slices and to give only the part of the HTML that you know for sure that the information is inside it.
Okay. Thank you for the presentation. According to your evaluation, what is the best speech-to-text model for Armenian language?
I guess for Armenian language mainly, I could speak about the models that came from the podcastle, or now it is its name is Async. My main work was done with English languages, and for English language, if I can recall it correctly, it's Cartesia, I guess. Thank you.
Hi, thank you for your speech. So actually, I have a question.
Can you speak up a little bit?
Louder. Have you ever measured the latency of this pipeline? So, and actually, have you ever tried like multimodal models to replace this pipeline from voice query to the speech query and as output?
The first question, rather whether I tried check the latency. Yes, every time. In every running, because that is the main evaluation technique that we understand. I understand where is the bad part, the heaviest latency coming from, and for example, if it is from STT to LLM, I've thought about changing either that pipeline or the main model itself. Rather if we used a multi-model models. I guess yes, we used it. We tried that, and the best approach was that mainly.
So what's the average latency?
Remember
the story about the conversation? Okay, go
on. Different parts of the pipeline were very much different. I can give you the exact numbers afterwards if you are interested in. It depends on what user mainly asked for. If it is the cached information or it is just something that the voice assistant doesn't need to go and search through the database, those answers were quicker. By the way, I would be happy to connect you via LinkedIn. That's the QR code of my LinkedIn page.
Maybe he can ask the second question.
Yes, sure.
Another questions I had that generating the text and sending to a STT, it's time consuming. So do you test that making a buffer for text generation, streaming, send it while generating its audio while LLMs still generate the text? For example, LLMs try to make 4 or 5 sentences together, and you send the first sentence to TTS and later second sentence, and somehow buffering the audio, and after the generations finished, play it for the user, make it more real time. Do you test this approach?
Yes, I guess I thought I have told about it, not to wait the full response to be received from one model to give it to another model to get the real-time approach. So when the first sentence from a user is gathered, it is directly given to LLM. And the same way when the first ready text to give to a user, like the first meaningful sentence is received from the LLM, it is directly given to the TTS to receive the real-timeness. Thank you.